Hello everyone, my name is Charles. I'm going to be teaching you guys about an Arduino computer vision demo today for ShellHacks. So super happy to have you guys here. Really appreciate you guys coming and watching the video. If you guys throughout the whole video have any questions, make sure just to comment down below, and me and maybe a few of my other committee members will help out with helping you if you guys have any questions. Keep in mind that we're going to be using two operating systems, so whenever there is relevant information on the Mac side, since I'm going to be using Windows, I will include that part for you to some extent. So without further ado, let's get started with the Arduino Computer Vision Workshop. So first of all, what are we going to be learning today? We're going to be learning the basics of Arduino development. So you'll be learning about different components on Arduino, getting familiar with the IDE. You'll also learn how to use different libraries for Python, as well as for Arduino. You'll also learn how to communicate using Python with your Arduino. So Arduino is supposed to be programmed in C, but because we have serial communication, we're able to communicate with Arduino using some Python scripts. And what that will allow us to do is to have some fun and tinker with a little bit of computer vision. So then we'll also be learning about computer vision, some of the different concepts there, as well as some of the calculations that's done to figure out where the face is. So I haven't really talked about what we're going to be doing for the demo, but essentially we're going to be doing a face tracking software that controls your servos. So then you would be able to connect your camera, or put a camera onto that servo, and it will essentially follow you. So later on, if you would want to continue development of this, you would be able to maybe mount it somewhere and have it record and have that move to that face that's being tracked. And then we're going to be learning about how the face is tracked, maybe some other stuff that you could track if you wanted to, maybe animals or cars, license plates, that type of stuff. So yeah, we're going to be learning a lot for sure. For starters, what is an Arduino? So an Arduino is referred to as a microcontroller. But it's basically a PCB board that has a microcontroller along with a few other features and chips that are included in it. What an Arduino allows you to do is it allows you to take information, take inputs from things like a button or a sensor or a potentiometer for some examples in terms of what type of inputs that you could get. But you could also output signals and output different data. Whether that be a motor, turning on a light, sending a tweet, maybe things like that. So to give you a little bit more insight in terms of how the Arduino is like the different pins that it has and the different connections that it has. So we have general voltage power pins. So we have a 3.3, we have a 5 on the left over here. Let me put a pointer. Yeah, so we have a 3.3 volt, 5 volts. We also have ground, so this is when you're connecting different things that require power. So like for example, maybe a DC motor will require 5 volts. You would be able to power it from this 5 volt. Depending on how many DC motors you have and all that. But we also have the analog pins. So analog pins are those that are variable. So they're not ones and zeros, they're values from 0 to 255 or more. I believe the analog pins go up to, I don't know if it's 8 bits or 16 bits. So the range of values that you could get from the analog pins are very high. But in general, an Arduino is not capable of doing any analog signals itself, which is why we use the Arduino has a an A to D converter, so an analog to digital converter, and in the other aspect it has a digital to analog converter, which, as you can see over here, these are the digital pins, and the PWM pin are the ones that are able to take those digital values and digital inputs and turn them into an analog signal. As well, you can see there's a few characteristics or classifications here. These are protocols. They allow communication through different embedded systems and microcontrollers, things like AD to DA converters, as well as connecting to things like embedded systems. But to give you a little bit of insight, the I2C is a serial protocol for two-wire interface to connect to low-speed devices. So, like I said, microcontrollers and those types of chips. You also have UART and SPI. So they're pretty much similar. They both support full duplex communication. Essentially, what all these are is serial communication that allow you to communicate with different devices through their serial ports. And SPI as well, that's synchronous serial communication interface, which allows also for short distance communications. But in general, you're able to do a lot of things with an Arduino. You could connect Bluetooth module so that you could communicate with it through Bluetooth. You could also connect different sensors like ultrasonic distance sensor, that type of stuff. But why is it used? So first of all, we have open source. So Arduino is a really big community on the hardware development side of things. So that's why Arduino provides you with a lot of schematics and PCB designs and firmware and software. And it's all open source so that people are more interested and able to develop with it as much as they want, because they have access to the inner workings of the actual Arduino. And that also gives access to cheaper Arduinos that are made by other companies, and further making it so that more people could develop and get those skills in programming and hardware development. But yeah, with that open source comes a large community, so that also means that there's a lot of libraries. So if you're not super familiar with coding and programming, whenever you are programming something, there's people and companies that create libraries for you to do things and functions that are already pre-made for you, so you don't have to write that code yourself. So whether that be maybe a library that gives you all the time in the different locations of the world, specific to maybe where you are or where someone else is, or also maybe a library that makes it so that the readings that you get from an ultrasonic distance sensor are more accurate. And you could look them up. There's a lot of libraries out there that do a lot of really cool things, and essentially make it so that programming is easier for us, and we could create and make these really cool projects. But Arduino is a simple programming environment, so it's not hard, especially Arduinos are made for beginners, but there are also access to advanced topics. So it's a really good platform to use and really good hardware to program on. It's also really inexpensive. So like I said, it's open source. That means there's a lot of cheap copy boards. You could probably get one shipped for about $7 in less than a week. You would have to look up the Uno R3 or things like that. But there's a lot of other companies that make clones of Arduinos, so take advantage of that if you want to get into programming and development, if you haven't bought one for this demo. But let's speed up things, because I feel like maybe I don't think you guys are bored, but I don't want to keep talking or stay on the same topic too long. So to finish up the topic about why we use it, it's also multi-platform, so you could use it on your Windows, Macs, and Linux. There's no issues there. as well as it's a USB programmable. So what that means is that all you have to do is plug it into your computer and upload your sketch from the computer, and your Arduino will do whatever it is that you programmed it to do. So it's not too difficult, especially if you're just using an Arduino. Once you get into a lot of different circuits and different components that are separate from the Arduino, it does take a little bit more development, but it's not too long or too difficult. So without further ado, let's start setting up the programming environment. I'm going to assume that a lot of you have not set this up because it wasn't required you to do so. And the reason being is that I wanted to do this with you guys, just because whenever we start downloading Python, you have to put it in your system variable path, so that your computer's kernel and terminal have access to that and can communicate the program language to it. So as you can see on the screen, let's go ahead and download the IDE. I'll go ahead and do this with you guys. I currently have Arduino installed, but let me uninstall it really quick. I already uninstalled my Python version so that I could do that with you guys. Yeah, so let me uninstall that so that we are 100% going and doing this together. Alright, so while that is downloading or uninstalling, let's go to the download. Okay, so we're going to go ahead and install it for your respective operating system, and just follow along. Okay, so the website is arduino.cc/en/main/software. Go ahead and download it for your operating system. I'll go ahead and get the Windows installer. I'll also just install. Okay, if you guys again have any questions, make sure to comment down below and let me know. I'll make sure to comment down below, or comment back in your replies. Alright, so we're going to download Arduino IDE. Make sure to follow along. And then we'll download Python after. So to give you a little bit of insight in terms of I guess what you're going to get out of being able to communicate with Arduino and using Python. So it's a really good tool because since Python is really good and simple, but and also a high level of programming language, it allows for image processing as well as object detection. The two environments communicating between each other make it a lot more interesting as well, and makes it so that you could do a lot of like really cool and exciting projects. But Arduino uses its own programming language, which is similar to C++. However, it's possible to use an Arduino with Python, so that's what we're going to be doing today. So yeah, let's wait for that to finish. If it takes too long, then I might just cut to after it's done downloading. But we'll give it a few more seconds. Okay, it looks like it's complete. Let's go ahead and make sure it's downloaded. So Arduino Perfect. Right now it's telling me if I want, or my Windows Defender firewall has blocked some features. I usually just put the recommended, so private networks, and I uncheck public networks if this is also coming up for you. Okay, so there we go, we have Arduino IDE. Perfect. So now let's see what's next. So now we're gonna download Python 3.8. You guys can follow this link right here. I will put these links in the chat as well. You guys can also follow along with this with me. What I would say is that with a Mac, the Macintosh operating system, it is a little bit different. So I will be making a separate sections of this video throughout, where if Mac has a relevant different way of doing something, while it's not very different from what we're going to be doing, because Python and Arduino are multi-platform, it won't be a huge issue. It's just a one-line commands or putting the path somewhere on the computer. So don't worry about that. But yeah, so go ahead and get Python 3.8.5. You could go to python.org/downloads and scroll down to here, look for a specific release, and we're gonna find the latest version of Python. So we're gonna click download here, and then we're gonna scroll down, and then depending on operating system that you're using, you're gonna get the installer for you. So Mac OS 64-bit, that would probably be for Mac, yeah. And then what I'm going to be doing is the executor installer Windows. We're going to download that again on downloads. Okay, we'll wait while it downloads. Depending on how long the workshop is, I may cut it down into sections, or I might just leave it. And if this is on YouTube, then you could probably put this on 2-speed during this section so that they go a lot quicker. If not, you could probably just cut until the download is over in the video and do it that way as well. Also, this is I guess my first time doing a recording. I've done virtual workshops before, or actually I've done workshops before, but I have yet to do a live virtual workshop, which I'm going to be doing at ShellHacks for the Arduino Thinkercad workshop. So if you're watching this right now, before that workshop has started, maybe go check that out, as well as the Fusion 360 workshop if you're interested in that, in 3D modeling. Okay, so we got the installer. Let's go ahead and run it. So if you're on Windows, make sure you do what I do right here. You're gonna first click on add path 3.8 to path, or add Python 3.8 to path, and then once we click on there, then we could click install. What this allows us to do is make it so that we don't have to go specifically to the variable location. But in case you guys already have a version of Python, what I would say is I'll teach you guys how we're gonna go about going or moving away from any issues in terms of if you do have another version of Python and that's the one that's recognized. As long as you're using version 3 of Python, I don't think that there should be any issues. But if you do want to stay, and then we could just go ahead and close this. If you do want to follow along, then I highly encourage you to do this right here. So we're gonna check that our path was included. So what I did there is I went to the search system environment variables. You're gonna click down here, system environment variables, and I usually keep my system variables on my system path, but you may have it under your user as well. So you would check that. As you can see here, for whatever reason, whenever it gets added to my path, it automatically did it to my user. So what I'm going to do to check to make sure that my Python version that I want is being recognized, I'm going to open up my terminal and just type Python. So as you can see here, I have Python 3.7.9, which is not the version that I want. And the reason that's there is because if I look at my system variables, we have here Python 3.7.2. So this may be different for you. Just if you understand so far in terms of what I'm saying, you could yourself check using the command line what Python version you're using. And if you're using the Python version that we downloaded, which is 3.8.5, then you should be fine. If not, then all you have to do is include those paths to the system variable as well, and then you should be fine. So what I'm going to do, since I'm having this issue myself, we're going to go ahead and highlight that, copy it, go over here to the system, we're going to add a new one, going to go all the way up. Wait, did that? I don't think I did that right. So we're going to add a new one, copy it, paste it into there, and then we're going to move it all the way up. The reason we want to move it all the way up is because the way that these environment variables work is in the order that they're placed. So if I place this Python 3.8.2 above 3.7, then that's going to take priority, and my Python 3.7 is going to be called once I refer to it through the command line. Alright, so that's what we did for the script. So we're putting two paths. The scripts, where are a few places in which we collect, or we don't collect, we have methods that we call to. So one of those are pip, and what pip allows us to do is download the libraries for Python. So we have the Python version in my user, and we also have the Python version in my system. Like I said, make sure to move it all the way up over any other version of Python that you may have. Make sure to keep scripts on top of Python. I don't think it really matters, but just so that we keep things the same throughout. So now again, let's open up the command line and let's check to make sure to see if it is now being recognized. And it is Python 3.8.5. Again, whenever you type Python, you're entered into the environment for Python. So here you would be able to type out different Python scripts. My Python isn't amazing, but that would be an example of what I mean in terms of being able to code Python within the command line. So now that we have that, we have to download a few libraries. So to do that, we're gonna again open up the command line. We're gonna do pip freeze, and what this does is it checks to see all the versions of Python that we currently have. And as you can see, I have the ones that we would be using for this workshop, but I'll go ahead and uninstall it once again, just so that you guys do it along with me. So I'm gonna uninstall all of these and then install them again. Okay, so let's try it again. Pip freeze, and we shouldn't have anything. Alright, yeah, we don't have any libraries installed. So now we're gonna go ahead and install them. You could do the same as I did with deleting them or uninstalling them, where I put a space in between each library so that you don't have to type it out multiple times. And this again will be different with Mac, which I will make a version of that portion of the workshop for you as well, and add it. Alright, so while that loads, just follow along and make sure to install all those. Oh. Yeah, but like I said, you don't have to type out 3 one by one. You guys can probably or do it like I did, in which I put a space in between each library. But yeah, make sure that the Python library that we're installing is PySerial. I'll tell you this now because I went through hours of debugging because I had made a mistake in which I downloaded a different library, and then once I downloaded that library, my program wasn't working, and I didn't know why, and I installed the library, it still didn't work. I come to find out that the reason it wasn't working is because I had to uninstall both PySerial and Serial, so that whatever glitch had happened that wasn't making my program run correctly would run. So once I uninstalled essentially all my libraries, I installed them once again, the ones that were necessary, which were pserial, OpenCV, and NumPy, and it was able to work. So you guys know in case you run into that error as well. So let's check again pip freeze. And pip is just a command that we use that allows us to access the Python libraries, as well as a few other Python commands. So it looks like we have the libraries downloaded. So now we could create a program that will check to see and make sure that the Python communication with Arduino is connected and is working. So first, what we're gonna do is we're gonna open the Arduino IDE, and then so you guys know what we're gonna do. First is connect the circuit, but once we connect the circuit, then we're gonna check to make sure that the port that we're communicating to is correct. So right now I'm gonna switch to to my phone camera, and I'm gonna show you guys how to connect an LED with a resistor, and then we're gonna have a Python script make it so that the LED can turn on and off through our computer, through the inputs in our computer. But what I would say before we get to that point is that if you don't have an LED or a resistor, no worries, there's no issues. If you could see right here on my screen, this pin right here, pin 13, is the one that we're going to connect the resistor to, and then to the LED, to the long side of the LED. If you have a breadboard, use a breadboard. Again, if you don't have this, it's fine. This light right here that says an L, if you look at your Arduino, if you have it in front of you, that light is connected to that pin 13. So the exercise that we're going to be doing is going to be done. You don't have to do it with an LED because the light is still going to turn on whenever you tell the Arduino to turn on once you use the keyboard input. So let me make sure it's recording. Okay. So we have the Arduino. I don't have my wire. Let me get my wire. Yeah, I'll probably cut this or some parts of it out so that it's not unnecessary time wasted for you guys. So we connect the, well, first of all, we leave that there. We're going to go to the Arduino. As you can see from the presentation, we're gonna put one end of the resistor to pin 13. Alright, and then the other end we're gonna put it to a breadboard. Now if you've never used a breadboard, it's pretty simple. Essentially all this row right here and this row right here are connected with an electrical plate, which allows you to have different connections that are transferring the signal, or a signal, or an electric signal. But from there we're gonna connect the long end of the LED to the other side of the resistor, and then let me make sure these are, so we're gonna do that. We're gonna put the long side of the LED to the resistor, and then if you have a wire, go ahead and get a female to female wire. We're gonna connect the other end. So these right here go this way, so there's a metal plate all along these that allow you to connect different components. So in this case you would connect the LED to that wire, and then we would go back to ground. The ground is right next to the pin 13, as you can see in the presentation as well. So there we go, we have it connected. Again, this LED right here on the board is going to turn on anyways, so we don't have to connect this LED, but just so that we could show you what we can do, we're going to be using that. Alright, so now that we have it connected, let's go ahead and check on the port that we're using. So my port is COM for Arduino Uno. For me it comes up. For you it might not say Arduino Uno, it might just say the port. In order for you to check what port you are using, let me show you. You're going to go to the search engine, you're going to go to Device Manager. Once you're in Device Manager, you're going to go down to serial. Where is it? No, ports. Here we go. Here. You go to ports, and you'll see the Arduino Uno. So you'll see something similar on your end that will tell you what port to connect to if it doesn't come up on the Arduino IDE. So I'm connected to it. So now let's go ahead and create the program. Okay. Let me leave that on so you guys can see that. So if you've ever used an Arduino IDE, essentially the way it works is that you have a setup method, and then you have a loop method. These are default methods that Arduino has that allows you to program the Arduino in a certain way. So essentially what setup does is that's where you would put the code that you want to initialize, or you want the Arduino to run as soon as it starts. So in this case, this would be opening a serial port, or making sure that the pins that you're using are recognized and assigned. So let's go ahead and I'll go ahead and copy along the code that we have here, and you guys can do the same. So on top of the setup, we're going to do an int LED 13. So what this is doing is that we're telling the variable 13, or the variable LED, to go to 13 or use pin 13. And then we're going to create another integer, which is going to be the variable data, and that's where we're going to store the data that we get from the Python. Right. So then we're going to do serial begin, and then we're going to put 9600. And essentially what that number is, it's I believe they call it the baud rate. It's the amount of bits that you're able to transfer through a serial communication. We're opening it, so then if and when the Python script communicates to this same rate, it allows that to communicate. Because if they're not the same, then they don't have that access. So yeah, just go ahead and copy along, and then I'll try to explain while we go. So here we're telling the Arduino which pin to use. We have to in order for the Arduino to communicate those signals to that specific pin. And then we're doing a digital write. And since the LED is either a 1 or a 0, which is the low and the high, we're telling it to turn on or turn off. Okay. So now we initialize that. So now within the loop, this is a loop that is constantly running. So throughout the whole process of the Arduino working, it's going to constantly do this. So what we're going to do is we're going to create an if statement. And this statement is basically a conditional statement where whatever is inside the if statement, if it's evaluated to true, then whatever is inside the if statement, curly brackets, is executed. So here what we're checking is to make sure that the serial port is open. And if it is, then we're able to transfer that data from the Python script back to the Arduino. And then within that if statement, we're going to do another if statement. This is a good segue into what's known as nested if statements, where essentially you have one conditional statement within another, and that makes it so that you need both to be correct for them to all process. But if you have the one inside the outside if statement and that one's not processed, depending on where you put those, I guess what would it be, like lines? Yeah, so essentially, if you put this inside the if statement, then it won't run if this is false. But since you have it here and this is true, then this will evaluate, or this will execute. So then we do serial 1 digital right. So we're gonna again tell the LED to turn on when they receive the data of 1, and this data is received as bits, or bytes, sorry, or no, bits. And I'll explain that once we go to the Python script. Okay. So what we're doing here is that we're just doing a print statement to let the user know that it is on, or it did turn on whenever the number was pressed. And then again we're going to do another nested if statement within the first outer if statement that's going to check when data is equal to 0, and that would signify the LED turning off. I need to look at the camera more, I'm sorry about that. Yeah, so that's basically what the Arduino program is going to be doing. It's just receiving that data from the Python script and then changing the LEDs accordingly. And this is similar to what we're going to do later on, but it's going to be a little bit more complicated. So now that we have that ready, make sure to save it. So once you save it, let me show you how saving it is. So let me go here. So to save it, oh yeah, you know how to save it, but the reason that I wanted to do this with you is because to make sure that you know that both the Python script and the LEDs and the Arduino script have to be in the same folder in order for it to work properly. So you could just name it LED, it's fine. Put it inside the LED folder, and now we're gonna create a Python script. So now go ahead and go to your file explorer, go to where you have the file that you just made, and then I'll show you now how to do that. Okay, I actually have it in the wrong folder, but it doesn't really matter. So hello everyone again. So you are definitely gonna see a different view from what you saw last time, as well as you're gonna be looking at a different desktop if I do exit from, or once I exit from the presentation. I decided to do this for a few reasons. One, I was getting this really strange error on my Windows computer, and I was trying everything to figure it out. I could not figure it out. I think it had to do maybe because I deleted my software for my webcam, and then after that it was causing problems. So I'm on my laptop now, so we're going to be using two different cameras, the camera on my webcam for the presentation, and then we're going to be using the USB camera to display the face tracking that we're going to be doing today for the demo. Where we last left off, we had written the Arduino program. I ended up changing one little thing inside the program. If you can see here on the bottom left, I put an else instead of the if in front of the if, because it was causing issues where the communication with the Python through to the Arduino wasn't communicating correctly. So whenever you would type in 1 or 0 to change the LED to on or off, it wouldn't recognize that. But now with this, it should work. But we have, like I said, we have we have the Arduino code programmed. Here it is. So let's go back to the Arduino cam. Alright, go ahead and make sure that you connect your Arduino. And then we're going to upload that Arduino code. Once we do that, then we'll start on the Python script, and then we'll check to make sure that there is Python communication to the Arduino. So in order to make the Python script, we're going to go ahead and pull up idle, Python 3.8. Again, this is the same environment, same version of Python, same libraries, all the same, just a different computer. And again, every computer may be different. You guys may have yourself find bugs or issues yourself. Try to decode it, try to debug it yourself if you can. You could also ask in the comments, and me and a few others will try to help you out with that. But anyways, once you open up the Python shell by running the Python idle, by going here to the search bar and typing Python, you'll find Python idle. Click on that. You'll get this. So after that, you're going to click here, file, a new file. And then from here, you're going to go ahead and just save it now so that we don't forget to save it. We're going to put it in the same location in which we have the Arduino code. So I made a new folder. You should still know or remember where you had downloaded it. So then we're going to go back in there. We're going to name this LED as well. But this is going to be a Python file. Alright, so now that we have that there, let's do this. Let's do that. And let's go ahead and follow along with the Python script. And I'll explain to you while we go through it. So we're going to import the serial, or input serial. That's the library that we had previously installed using pip install PySerial. They do have different names. That's just the way that they made it for the actual library within Python, but the one that you have to download is PySerial. So now we're gonna try to access that serial communication to the Arduino by using this command. Make sure to put the port that your Arduino is connected to, or your Arduino is using. Like I showed you previously, you could go to your device manager and it should tell you there what it is, as well as through the Arduino IDE. And now you put 9600. That's the bad weight, or sorry, the bad rate. That basically tells you how many bytes per second, or bits per second. I always get confused, but it's basically making it so that you can transfer a certain amount of data through serial communication to the Arduino. That's why when you wrote the same line or similar line of the 9600 in Arduino, they have to be similar in order for them to communicate. That's one of the requirements for that communication. So what we're doing here is that we're creating a method. So in Python it's a little bit different. To create a method or a function, you put the def and then the name of the function and then semicolons. Then under there we're going to go ahead and start writing this function or method. So user input, that's going to be a variable that we're creating. The good thing about Python is that you don't have to initialize or declare what type of variable it is. It does it for you, which is pretty cool and convenient. So this input command here, what it's going to do is going to ask the user for an input through the console or through the terminal, but you can also allow it to display a message to the user so that they know what to write. So just go ahead and do enter 1 to turn on, the LED, and 0 to turn off the LED. Let's put this in quotations. Quotations. Cool. So that's that. Okay. So after that, we are going to make an if statement. This if statement is going to check to check to see what it is that the user inputted. The user inputted 1. Then it's going to output or communicate that 1 byte to the Arduino, and then from there the Arduino is going to turn on the LED. So yeah, so if user input equal 1, then Arduino.write, this is where we communicate that data back to the Arduino. And the data that's being transferred is in bits, or bytes, sorry. So make sure that whenever you are transferring that data, you put B in front of whatever it is that you're transferring. In this case, it's a 1 since the user pressed the 1, and we're going to recognize that back in the Arduino code in order to turn on the LED, basically. So this is just some print statements, nothing really to explain here. Also, I'm not completely comfortable or used to this keyboard, so bear with me. You will probably be able to code this way before I do, so that'll be good, because most of the time, whenever, for me at least, I tend to go pretty quickly in the presentations that I do, so this might be a little bit better for you to catch up in terms of writing the code. So the reason that we're doing the sleep here is that usually whenever you're doing these types of commands, you have to wait for that communication to happen. If it doesn't, then the program can be out of sync and then it'll just not work properly. So that's why whenever we do that type of communication, we want to ensure that there is some type of delay, and that's why we use import. That's why we import time, and then that's why the import .sleep basically puts the program in idle while it's doing all these processes. elif, that's basically else if. So if the first if statement isn't correct, then we're going to do the other if statement. It's also a little bit difficult to write on this keyboard specifically because it doesn't have any lighting on the keyboard. And right now I'm in the dark room. I could open the blinds, but it would make it pretty bright in here. You probably wouldn't be able to see me very well. So yeah, let me concentrate on the code so that we don't spend too much time, because we're already pretty deep in, and we still have a little bit of content to go over in terms of computer vision, that type of stuff. You know what? I'm going to assume that most of you already copied this because no, I'm definitely not good at typing, especially on this computer. So I'll just go ahead and copy and paste this into the Python script. What I would say is that if you guys also are having trouble typing it for whatever reason, I will be providing this code for you. But I still do want to go through the code so that you understand it and know what's happening. So I'll just go through it really quickly and then we'll move on. So yeah, here we're checking to see if the user pressed 0, the number 0. If they did, then we're going to print to the console LED is off. We're going to give it a delay and then write that bit to the Arduino. After that, if the user didn't put 1 or 0, but rather quit or Q, then the program will exit and finish executing, and it'll close that serial communication. So right here, Arduino.close, that's closing that serial communication. This is pretty necessary because if you don't close the serial communication, and then let's say later on you want to communicate through the serial communication with Arduino, it's not going to allow you. So always make sure to have this code, this line here. And it's also gonna make the LED go off just because we don't want to leave that LED on if we stop executing the program. But if not, if none of these are executed, then we'll go to the default else, which makes it so that if none of what was required to be typed was typed, then it will be an invalid input and it will run the program again, or the method, so that it would prompt you to enter another digit or character. Again, we have the time.sleep just so that we could have some delay between the executions, and then we run the code again. If this else isn't, or if this one right here, if the close isn't executed, we'll run it again and then ask the user again for that communication. So let's go ahead and save it. Looks like we have an issue. Alright, so it says check on your port. So this is something that you guys are going to have to check as well, and this is good that this came up so that you guys are aware. Always want to make sure that you're on the right port. If you're not on the right port, it's not going to communicate correctly. Yeah, so I need to change this to COM3. Alright, let's save that, and then run it again. Okay. Cool. So now it's prompting us to type 1. We're going to type 1. And nothing occurred. I wonder why. Oh, I don't think I uploaded it. I think I only saved it. So let's close this. Let's close Python program. Let's make sure that we upload the Arduino code. Again, if you couldn't make the actual breadboard with LED, it's fine, because like I said, the Arduino has an LED that's connected to that pin 13. Okay, let's try it again. Let's run the Python code. To run it, you go up here to run and then just click run module. Alright, let's try it. There we go. 1, it turned on. Let's put 0, it turns off. 1, it turns on. 0, it turns off. So we have Python communication to the Arduino. Perfect. So from here, this is great. Let's go back to the presentation. Let's talk a little bit about computer vision, and then we'll go to the actual demo of the presentation. Again, if you couldn't get that to work, make sure you have your port correct, not COM3, or COM3 if it's your port that's your Arduino is using COM3. Make sure that you have the bad rate to 9600 on both sides of the program. Cool. So let's go back to view. Now if you're up to speed, then you should have that communication there. And now we're going to talk a little bit about the computer vision aspect of the workshop. So ideally you don't have to, but it's a lot better for you to have a good understanding of how computer vision works so that you could know how it is that you're making these servos turn towards your face in any direction. So what is OpenCV? So if you haven't heard of OpenCV, OpenCV is one of the biggest libraries for programming stuff with computer vision. It's a library that has programming functions that mainly are aimed towards real-time computer vision. So different algorithms, different methods, methodologies are included in this library, as well as if you want to create your own I guess I would say XML files. I haven't gotten there yet, but basically what a hard cascade is, we're going to be using an XML file that has a whole bunch of feature sets for different objects. In this case, we're going to be using our face, but I'm also going to be providing to you guys a link to a whole bunch of other XML files that include different objects that you can track with. So yeah, so first of all, that's what OpenCV is. If you are interested in getting more into computer vision, I highly encourage you to look up OpenCV. There's a lot of cool stuff that it has. So what is a hard cascade? Hard cascade is a machine learning based approach where we use a lot of positive and negative images to train the classifier. What that basically means is that the positive images are the images that contains the image or the object that we want to classify. In our case, we're going to be using a face, but you could also use license plates, cars, eyes, nose, and we're going to get into how this algorithm works. And it was originally made by Viola Jones. That's why it's called the Viola Jones algorithm. But also something to know and recognize is that a lot of computer vision also uses neural networks. We're not going to be dealing with neural networks in this presentation because it is a little bit more advanced topic. But to give you a little bit of insight into what neural networks are, they're essentially layers in which in each layer you are using features and those features of different characteristics. So for example, your nose or your eyes or whatever it may be, those feature sets go through layers, and each node within those layers make a prediction that further classifies whether that is a correct classification or not. It's a little bit complicated, but the reason I bring it up is that these two algorithms are mostly used in image processing, and neural networks tend to be the better algorithm to use when it comes to this stuff, just because it makes its predictions by training rather than by classification. So if you give a classification edges and line, so yeah, that's a little bit about, sorry about that. There's a little bit about hard cascade and neural networks. Hard cascade is a little bit easier to explain in terms of how it works and how it's making those calculations, so that's what we're going to get into in the next slide. So starting off, hard features, what those are and how that works. So basically with hard features, you're given edge and line features. So if you can see right here, let me use a pointer. If you can see right here, these are edge features. What edge features are, they're basically ideal pixel intensities in which you can compare the pixels on the screen, and by comparing those pixels, you're able to identify whether that may be a feature that we're interested in, whether that's a face or an eye or a nose. So in this example, we have a grayscale image, and grayscaling is very important when it comes to this type of algorithm, because it makes it so that you can actually process the pixels and the values that these pixels have, rather than if you had an RGB picture, it would be a little bit more difficult. But essentially what hard features does is that it takes those dark shades in the picture and compares it to the light ones around to make that classification. So usually your eyebrows are a lot darker than your eyes. Your nose bridge is a lot lighter than the side of the bridge because of the lines that you have. and all that stuff inside the picture is used to classify. So to give you a little bit more in depth in terms of how that classification is done, this right here is an ideal HAR feature where the dark pixels are 1 and then the white pixels are 0. So this is ideal, but essentially what you're doing is that you're getting the difference of the dark pixels to the light pixels, and depending on what value you get from there, you can further classify whether it is a feature that you're interested in, and then you could further calculate to make sure that that's a face or whatever it may be. So what you're doing basically is you're gonna sum up the white pixels, and then you're also gonna sum up all the black pixels. You're gonna take the average of those, and then you're going to subtract it. And then depending on whatever value you get, if it's closer to 1, then it's more ideally going to be a feature that's correctly classified. If it's a little bit less, then it's less likely that that feature is something that we're interested in which case we would just discard it. So yeah, now let's get into a little bit more in depth in terms of the processing that's being done. So this stuff takes a lot of features from a picture. I believe the number is around 16. Oh, sorry. Yeah. So the features could be from 200K, and every time you do those averages of those pixels, you're using the quadratic formula. And what that's causing you to do is that processing time, or that big O of the original image that you're processing, is going to be n to the power of 2. If you don't know what time constants are when it comes to programming, basically it measures the amount of time that it takes for you to complete something or complete an operation. But if we use integral image, which is something that was developed for this, you get a faster processing time of big O of 1. And that's a lot quicker, and which is we want, because obviously we don't want it to take long for you to be able to classify your face if you're doing, for example, face tracking, camera gimbal. So what integral images is, what you do is that you take the values. So in this example, what you're doing is you're taking the values, or the sums of all the pixels from the left and on top of the pixel that you want. So how that works, sorry about that, how that works is that if we wanted, for example, this right here, these set of pixels, then what we would do is that we would get the sum of this pixel, which would be, in this case, it would be adding these two, so that's why 0.2. And then similarly with all these, 1.7 is going to be all the pixels on top of it and onto the side. And ideally, what this allows us to do in terms of making the processing time faster is that we're, instead of adding 6 numbers and then getting the average of that, which takes time, we are getting the sum of the pixels that we're interested in and then subtracting them and adding them to then get that same value that we would originally get. So if you were to add these values right here, it would come up to 1.7, which is the same thing as if you were to add and subtract these right here. So since we want these pixels right here, we would get 3.7, and we would subtract it by 0.5, since that's not one of the pixels that we're interested in, and so on and so forth. It's a little bit confusing, but hope I explained it well. You could probably look more into it if you're interested. But other than that, there's also cascading and add a boost. So when it comes to add a boost, one second, let me pull something up. Yeah. So the way cascading works, or sorry, not the way that AdaBoost works, is adaptive boosting. It's a machine learning method where you try to learn from the mistakes of the weaker classifiers and turn those into stronger classifiers. So in that case, wherever you see that something isn't a feature that you would use, you would just discard it instead of keeping it. And then that way you have less stuff to classify, and in return have a better outcome or prediction that you could get from these algorithms. And cascading is a similar thing, in that whenever we analyze a picture or a video or an image, when we classify the face, let's say for example we want to track eyes or nose. Once we classify to the face, we discard everything else that isn't the face and only focus on the face and whatever's inside the face. So by doing that, we're able to check if a part of the window is not a face region that we're interested in. Instead of focusing on those areas, we focus on the areas of the face, basically. But yeah, so it allows us to make the classification and the cascading of the image more precise, more accurate, because instead of considering those parts of the image that aren't necessary, we're only considering the ones that are. I hope I explained that pretty well. I've had a lot of it could be a little bit complicating at times, but if you do have any questions, just make sure to comment down below and I'll try to explain it better if I can. But okay, now let's go ahead and start building the tracking gimbal. So I'll go ahead and go to the other camera and then show you guys how to make it, how to connect the servos, and then we're going to go ahead and start programming the code that we're going to use to make this face tracking work. And then I'll show you guys a little example in terms of how you could use this to maybe set it up in your room and it would follow the person that's maybe walking. But yeah, let's go over to the build center. Let me turn on the lights because I'm not sure it's very viewable. Oh my goodness. You know what I just realized? I mean, the recording wasn't recording my voice because I turned on the mic. But luckily I was recording. Here. Check. Hello? Hello. Okay. Okay. So, let me check. Is it recording? Okay. Oh. Okay. So let's start by assembling the gimbal, and then from there we'll connect the servos to it. So initially, what you're gonna have to do, so within the servo packets come these white parts that connect to the servo. What we're gonna have to do is we're gonna have to cut that a little bit so that it can fit inside the gimbal. I'll do this along with you guys as to guide you through it if you don't know how. Right here. Okay. If you guys have a scissors or more sharper tool, you could use that, but just, be careful. We don't want anyone to get hurt. Okay. So I'm going to be using these right here, but if you guys have scissors, you guys could also have scissors, but again, just be careful. So what you're going to want to do is that the three dots, or the three holes that you have here, you're going to want to leave those because the screw that you're going to be putting is going to go on the third hole. So make sure not to cut that third hole. If you can, just cut it a little bit above the third hole, and that should be good in terms of allowing it to enter the gimbal and then putting on the screw. be careful with your eyes or anything around you. It may go all over the place. Okay, so from there, we're gonna go ahead and put this inside the gimbal. We're gonna put it vertically or horizontally, sorry, with this facing that way. Alright, so from there, we're gonna get these screws that come also in the packet for the white parts of those servos. We're gonna get that like this. Use the screw that came in the box if you have it, or if not, you can use any screw. Then we're gonna go under it. We're gonna go ahead and start screwing that in, and it should be able to. So the holes might be a little bit small, but the screw will be able to go in. So if you can, just go ahead and start screwing it inside that hole. Once you get it inside that hole, try to put that white part into place, kind of like that, and then you can just start screwing from here, and it'll go through that white part. Hopefully you guys can see. Yeah, and there you go. So now we have that through that screw, and now we're going to do the other side. You could also look at the picture that I have on the presentation to get a sense of how to orientate the servos once we get to that part. But I'll guide you through that, so no worries. Okay, perfect. It seems like I got it through the second hole instead, but in reality it doesn't matter as long as you get it secured in there. That's all that really has to happen. Okay. So now that we have that there, we're going to go ahead and put the servo. Make sure to follow the orientation of the picture that we have here. So in that case, we're going to have it in this orientation. The long side of the base going to go backwards, and then this is going to be pointing forward. Make sure that the servo is not locked on one side, because if it is, then we're not going to be able to turn it in the direction that we want to. So make sure it has a 180 turn from the middle. So I'll try to. So right here it's locked, right? So since it's locked there, then we could put it here facing left, and we know that that's going to be 90 degrees, and then that's going to be 180, and then that's going to be the other 180, or the 0. Okay, cool. So now we have that. So now what we're going to do is we're going to get these two. If you have a different gimbal, because obviously I believe, yeah, in the requirements you guys could have gotten also a 1 servo gimbal, which is also fine. It's probably going to be a lot better in terms of the direction that it follows, because it's going to have a little bit less to focus on in terms of what it's grabbing onto. And also, if you do end up putting the camera on there, then it will be a lot easier in terms of the weight. But so now we're gonna put the servo. So let's see how this goes. So we see here that this has a little bump right here that's supposed to go in this part right here, and then we have this white part of the servo that's gonna go through this hole. So then we know that it's gonna go in this orientation. In that case, then all we have to do is put the servo like this, facing this, and then put the screws through there. I'll speed through this if it takes too long, just so until you guys have the correct idea of how this thing goes. Alright, the hole on the actual gimbal is a little bit small, but it still goes through. You just have to screw it in, and then once you screw it in, just put on the nut. I don't know how well you guys can see me. I apologize if it's not too well. This is the first time video, you know, where we're trying to integrate hardware, especially with everything being virtually. It could be a little bit difficult, but hopefully you guys get worth information and worth experience from this workshop. It did take a lot and a lot of hours of debugging, a lot of issues, but hopefully it turns out good for you. Okay, so now that we have that through there, carefully put the nut back onto the screw. It might be a little bit difficult if you don't have small hands. I don't have super small hands, but I think I've gotten enough practice of doing this to the point where I kind of know how it goes and how I can do it. Again, make sure that you're putting the screws in this orientation because the wires may be a little bit difficult to deal with the screwdriver. Okay, so we got that screw in. We're almost done. Let's go ahead and one thing I forgot, but I'll do that right now. Let's finish screwing in this nut. Perfect. Okay, so we have this connected and we have this. One thing I forgot to do with you guys, we need to also add the screw that's going to make sure that the servo doesn't move from the white plastic part that we added to it. So we're gonna get that small screw that also came in a little baggie with those servo parts, and we're gonna go through the middle of the hole and screw that there. So that now it's stuck in there and it won't move. Okay, so we're almost done. Only other thing would be, so we also have this white part. You're also gonna have to cut it, but it's gonna be a similar process. Just ensure that the fourth hole, there's 4 holes in that little wing part, and then it should be able to fit inside the little slot that we have here. So we're gonna go here to 1, 2, 3, 4. So we're gonna cut off the last 2. Now the holes actually don't matter because we're gonna be only screwing it on through the big one directly to the servo. So now what we're gonna do is we're gonna put this in this orientation. You may be even able to get it a little bit further out, but in this case it doesn't really do anything. So now that we have that screw there, again we're going to want to do the same thing in terms of the orientation of the servo and where it is in the angle that it has, so that we can be able to manipulate it with the program. So since that's going to be here, that's the 180, that's going to be 90, that's going to be 0, right? For the most part. So then ideally, if we connect it this way, it would have to move down all the way. So let's screw this like this, and we're gonna move it to the opposite direction until it locks there. So essentially once we put it in here, it's going to be able to move all the way up here and all the way back. Understand? Cool. So now let's put that in there. We have the servo angled correctly, and let's go ahead and put that through there, and then also right here push this a little bit, and this should help you push that in there. Again, make sure to connect the servo part to the wingtip. And now to ensure that that wingtip stays there, we're going to get the other small screw that came inside the servo baggie, and we're going to put that on the side right there. So that won't move. And now we have our gimbal. What did I do? I think I did it wrong. No worries. Yeah, I think I just forgot to orient it that way, or down. when I place it in. So it's not too hard. Just make sure to connect this. If you have extra screws to, actually I don't think they have screws for this part. So this part, it doesn't have any screws, but I don't think you really need it. I've done this whole demo a few times and I haven't had any issues. So we have to place it in this orientation so that it can then move in the required. So then just make sure that when you are putting that piece in, you are putting it pretty face down or horizontal to the whole gimbal itself, so that once it does start turning, it can turn in the proper orientation and it has that degree of freedom. Alright, cool. So now that's connected, we have that there, and we have this here. Perfect. Alright, so how we're gonna make this have some structure and be able to not move if we need it not to move. You should have also had these screws right here. If you don't, it's fine. You could also use tape and tape it over a stronger base so that when it does move, it's moving in the correct orientation and you don't have to hold it in your hand. In this case, I'm not going to do that because we don't have too much time, and that's not too difficult to do yourself if you need to. But essentially what you'll be able to do after we get the program working, you would mount a camera or the camera that you're using onto this thing right here, put it somewhere that you would want it to record, and just have it follow the person or the face of the person that you're trying to monitor as a case that I could give you. But there's many cases that you could maybe use this or continue to develop and program with this. Take for example maybe a license plate tracker and having that placed inside your car. So there's a lot of different things that you could do. But this is more of a conceptual and topic and knowledge that you guys are getting out of this experience. Anyways, now that we have the gimbal connected, we're gonna go ahead and connect the servos. So let's do that. Like I said in the requirements of the hardware that you needed, you would have needed a few male and female wires. So essentially what you're going to have to do is you're going to have to connect. As you can see, so let me explain it in the diagram for a second and then we'll go on. So if you look at the servo has the an orange, red, and a brown wire. As you can see, the red ones are the ones in the middle. Those go to the 5-volt from the Arduino, and then you're gonna connect the brown wires to the ground, and to the ground that's connected to the Arduino as well. And those grounds are connected to the brown wire of the servos. So that's gonna be the far left if you're looking at in this orientation. And then we're going to use the PWM pins 5 and 6 that are going to be able to send that that angle that we want the servo to turn to face the person or the face. Okay, so let's go ahead and do that. I hope I don't know if you guys have ever used breadboards, but basically these lines right here on the sides go directly down, so anything that connects to it in this orientation is connected electrically through that metal connector. But any ones that are over here go side, so then you would be able to connect them through the sides, and we'll do that in this part of the presentation because some of the wires, if we don't have them, we do that instead. So go ahead and get your red wires. If you have any red wires, go ahead and connect it to the middle pin, which is the power pin. And we're gonna, like in the diagram, we're gonna connect it to the positive terminal trail that connects all these together. So that essentially what we would be able to do is just connect one source of 5 volts to that one connection, and it would power everything that we have connected to it. So we have the power cable connected to the breadboard. Now let's go ahead and connect the ground wire to the breadboard. And same thing is going to happen. We're going to go ahead and connect the brown wire of the servo to the negative side of the breadboard. Also, it doesn't really matter the color that you use whenever you're connecting these wires. But if you want to make it a little bit easier for you to know what's connected to what and not get confused, color coordination, I guess, is always a good thing to have. So let's go ahead and disconnect the Arduino right now, because since we're connecting the wires, we don't want to have any issues with the electricity. So what we're gonna do is we're gonna, like in the presentation, we're gonna go to the 5 volt, which is gonna be on the right side, and this orientation is gonna be this one right here. Is gonna be the 5th from the top, and then let's go ahead and connect the ground wire as well, and we'll use a white wire for that. So the ground is right under the 5 volt, so it's gonna be 6, 5 from the top. But just basically under the 5 volt. You could see, if you have an Arduino, you'll be able to see the lettering on the side and on the front, so that you know where you're connecting it to. So now let's go ahead and connect the 5 volts to the positive, and then the ground to the negative. And then the only other thing that we would have left to do is to connect the PWM pins that we send data and values to the servo to know where to turn. For those wires, we're going to be using the 5 and 6. So 5 is going to be, I believe, for the, let me see, right there, 5 is for the vertical servo, and then 6 is for the horizontal servo. But if you have only one servo, then all you're going to be really connecting is the horizontal servo, which is going to be connected to servo pin 6. So this is right here, this is my horizontal servo, the one that I connected to here, the bottom one. So from here we're going to go to I believe it was 5. Again, make sure that you can look on the side for the number and follow there. And then for the other wire, or for the other servo, which is going to be the vertical one, that one is going to go into, let me check again, 5 is for vertical, 6 is for horizontal. So this is vertical, so this goes for 5 pin, and then the horizontal one, 6 pin. So the bottom servo, if you have 2 servos, is going to go to the 6. If you have 1 servo, then it's also going to go to the 6, and then the one on top is going to go to 5. Okay, so now we have it connected. It should be all ready to go. So now we're going to go, before we connect the Arduino, we're going to go over the code for the Arduino, face tracking code, and then we're going to see how this is exactly using the data that's receiving from the Python script and the computer vision to then transfer it to the servos and have the servos map to specific directions. So I'll go ahead and write this with you. So another thing to mention is that you might get a few errors, you might not, depending on how you have your computer configured. What I would say to you to get you a little bit prepared and a little bit of insight is if you do have a camera that you're already using, actually we'll get to that once we get to the Python code. But no worries. What I would say is that all these files have to be in the same folder. And whenever you're making an Arduino program, you always have to put that Arduino code inside a folder of the same name. So this is the LED code that we use. We're going to create a new file. We're going to save this file, and we're going to put it wherever we want. I'm just going to go ahead and go to my documents and make a new folder. Actually, no. What you could do is save it, go to your documents, or wherever you want to, and put whatever is called face tracking code. Just put face track Arduino. Save it. Let's make sure to see where it's saved and that it's saved correctly, because like I said, you do need that inside a folder, and automatically it should make a folder for you. Yeah, I did. So here we go, face tracking Arduino. So this is where we're going to have the Python script as well as the XML file. Again, XML files are massive files that have a lot of feature sets, and these feature sets correspond to the specific type of item that you're trying to track. And how these XML files are made is through training. OpenCV also has some libraries that allow you to train your own images. So if you, for example, want to track glasses and you have never seen a XML file for glass tracking, then you could make that yourself. It's not too difficult, but it does take some time and some processing power. But that's all going to go in this one folder, because we need it all to be in this one folder. I will be giving you guys the link to the XML file, as well as the code for the Arduino if you don't want to write it along with me, and the Python script. But we are going to be going through it and explaining it while we code. So initially, we're going to, again, include the servo library. This is a library that comes already with your Arduino IDE once you download it, so there is no requirement to download something from the internet for this one, for this library specifically. And then we're going to define what servos these are. So we're going to define the vertical servo as well as horizontal. Make sure to put semicolons at the end. This is C-based language, C based language, so you do need semicolons. Alright, so we're going to declare and initialize these integer values. And these are going to be used to actually save and capture the values that are going to be passed from the Python back to the Arduino. And then we're also going to be making some integer variables for previous x and y's. Okay, now we're done with that. By the way, don't put this inside the setup, put it outside the setup. So you could do Control X to delete that, and then Control Z to put it outside of the setup. The setup is going to be used for something else. So for the setup, we're gonna again open that serial port that we're going to be using for the communication. We're going to be using 9600. It's just an arbitrary number, but it does have significance in the amount of I think it's the bits or the bytes. No, the bits that it's transferring. So it transfers 96. Let me check really quick to make sure I'm not telling you incorrectly. Yeah, so it's bytes per second. So 96 baud rate is 9600 bits per second. So you know. So now what we're going to do is we're going to attach the specific servo that we declared to the pin that we're using. So again, we're using pin 5, which is the ones that you should have connected to on your Arduino, and also servo horizontal to pin 6. And then we're going to write to the servos, and we're gonna make sure that they, when we first start the code, they are facing 90 degrees. And the reason we want that is so that they're not facing down whenever we start the Python code, and we have it a lot more structured in the way that it's moving. Now, what I would say, for me at least, the vertical servo was better whenever I did it at 60. Whenever I did it at 90, it was a little bit down. That might depend on the way that you again did your angling. We'll check it right now with the servo and we'll see what comes from it. But we have the setup, so now let's do the loop. So for the loop, we're going to check to see that the previous x values that we get are not equal to the already x values that we received from the Python script. And the reason we want that is because if they are the same, then obviously there's an issue in which the face isn't moving anywhere, and then the code stops running. So inside that if statement, we are going to create an integer, and we're going to call that servo x. This is the actual variable that we're going to use to write the angle that we want the servos to move, depending on the tracking of the face. So what map does, basically what it does is that, so the x value that we're gonna get in another, so first of all, what you're gonna want to do is, instead of this loop, we're gonna make that loop called pause. And the reason we want that is because we're creating another method. The loop method is gonna be something differently. So just go ahead and do that with the loop, and then we're gonna create another loop where we actually initialize and run the code. So what math does is that we take the value of x, which we're gonna be getting once we start the loop, and then the range of what we receive is from 600 to 0, and the range in which we want it to output is from 70 to 179, and these values are variable values, in which, what I mean by that is that you would have to check to see what are the values that you're receiving, so that you can configure those or play around with those accordingly, which is why we put 450 to 0 for the y. That's the values that we're receiving from the Python script, but we want them to be outputted from 179 to 95. So we're basically scaling the values that we're getting into a different range of numbers, if that makes any sense. And these are going to be the numbers that we're going to be tinkering with if we want the servo to work a little bit better in terms of the recognition of the face and the way it moves. The recognition is already happening from the Python script, but what we're doing here is we're manipulating the movement of the servo to make it move a little bit better or worse. Currently, the way I have it set up, the horizontal axis is pretty well. The vertical is well too, but not to the extent of the horizontal. Through trying to develop this workshop even better, I've tried to tinker with that, but I haven't had any super good success in having that servo move a lot, but it does move up and down, and you'll see once we start that. So let me stop talking for a second. Let me go ahead and copy this code. If there's anything relevant, I will mention it. If you guys have any questions, make sure to mention it as well, and I can answer that for you in the comments. So this is going to be for the y, or for the vertical. Okay, so what we're doing here, after we are done mapping the values that we receive from the x, again, this x that we receive is directly from the Python code, which is the one that the computer vision algorithm is giving us. After that, we get the servo x integer value, and then essentially what we're doing is that we're going to get the minimum from that servo X to 179, and then we're going to get the maximum that we got from this one, put it, and then we're going to get that value again and get the maximum. Reason we do this is just so that we can scale the data, so that the servo can recognize and move in the correct direction. So now we're gonna get that last value that we got from the servo max, and write it to the servo. Cool. So now that we have the position method or the pause method, we're going to go ahead and now create the loop. And this is where we are going to check to make sure that the serial is open, the serial communication is open, and so that we can, sorry, let me go here. So this is going to check to make sure that the serial is open and we can communicate with Python. So we're going to do serial available if it's greater than 0. Then we're gonna check another if statement, and we're gonna read that serial communication. Make sure to make the serial capital letter. The capitalization of the letters and the words actually really do matter when it comes to programming, especially with C. Not with all things, but with most things. Okay, so then what this does is that if it reads an X bit or an X byte, then it's going to then receive that data and make it equal to the X variable that we initialized previously. Parse int. So we're changing it to an int. So because it was most likely it was a float value, and the servos only take int values. And then after this, we're gonna do another if statement that checks to see if the serial receives a Y value. Then it captures that data and puts it inside the Y value that we had configured, or I mean assigned. Make sure those are capital as well. And then within that if statement, we are going to assign the Y to that data that we receive from the serial communication. And then we run the pause method, and since these variables that we had initialized up here, since we initialized them here and declared them here, they're global, so that means that pause will also have access to these values, and we don't have to pass it through the parameter of the method. We could probably do it that way as well, but this way works too. Okay, so after that, after we have received both the Y and the X values, then we are going to go ahead and check to see that there is still valid communication occurring between the two programs, so that it can again run the read function of serial to further grab more information and continue to output those values to the servo and have the servo move. Okay, it looks like we have everything ready from the Arduino side, so just go ahead and save that for now. And now we're gonna go ahead and write the Python script that is going to use the CV2 library, which is the OpenCV library. Take that frontal face default XML file, hard cascade, and then use those data sets and features to then compare it with our feature sets, and classify whether it is a face that we are looking at or not. And then do that, get those X and Y values, output them to the Arduino code, and then from the Arduino code output them to the servo. And then we have a face tracking gimbal. But let's go ahead and go over the code a little bit. I'm not gonna make you guys copy this because it is a lot of code. So I'll definitely just give you guys this code if you would like. If you would like to copy it as well, go ahead. Fine by me. So what we're doing here is the NumPy. NumPy is one of the libraries that we downloaded. NumPy is a very powerful library, and it has a lot of methods that we use whenever it comes to machine learning. And then we also have the serial library that we use, that we also downloaded, that allows for that communication to the Arduino. We have the time for the .sleeps that we're going to use, so we could allow that there to be some processing time in between. And then we also have the CV2, which is the OpenCV library, and that's what's gonna allow us to create the boxes, create lines in our image, take those data sets that we receive from the image that we're capturing of my face or your face, and then classify them with the ones that we're using them to compare them. So a few things to note. First of all, whenever we do serial.serial, make sure that your port is the one that you have on your Arduino. If you have a wrong one, then it's not gonna recognize it and it's not gonna be able to communicate. Also, the bad rate. We talked about this again. Make sure this is the same rate that you included in your Arduino code. If you have them different, then they're not gonna be able to communicate. Okay. So what we're doing right here, face cascade. We're creating a variable where we are going to house that information that we're getting from a method using that OpenCV library. Another method that we have with the OpenCV library is a video capture. This is what's going to allow us to use our camera to analyze the video and the image, and then further analyze and classify it. Usually this number is 0, but if you're using a different default webcam, let's say for example you are using your webcam to talk to somebody and you have another USB webcam, then you would have to use maybe 1. But the numbers range from -1 to 0 to 1 to 2 to 3. But most of the time there's 0. If it's not 0, then try 1. If it's not 1, try 2. Try -1, and you should be able to get your camera to be recognized by the Python code. So then what we do here, this is what's going to actually read the image of the face. So that's how cap is taking that data from the video, and then we're reading it and then putting it inside 2 different variables, one that's going to be image and then one that's going to be the rectangle. So then first of all, what this does right here, the CV2 resize window .line circle, all that does is it's creating lines and circles within our image, and you'll see this once I start running the code, so that we can be more familiar as to where to keep our face in the frame. But these lines of code right here aren't necessary. They just make it so that we have a more concrete structure of the camera. After that, we have the gray line. I wish I could move this. Can I move this? No. Okay. So I'll talk about the lines without moving down there so you guys could actually see it. But gray equals cv2.cvt color. What this is doing is taking our image and making it into a grayscale image. Like I mentioned earlier when we were talking about computer vision, this is necessary so that we can be able to take those pixels and the values of those pixels a lot easier than if we were to use RGB or fully colored images. After that, we have faces equals face cascade.detect. This is what's going to actually analyze the image. So as you can see, in one of those parameters is gray, so we're taking that gray scale image from the camera that we use from this image variable, and then taking it and then analyzing it, comparing it to the CV file that we have. Also, the numbers that you see on the bottom, these depending on the size of the image that you're using and the likelihood of the object, these numbers will change. But the ones that I have here are pretty robust values when it comes to the analyzation of the face inside the screen. After that, what we're going to do is that we're going to take the X values and the Y values and the width and the height that we get from the faces of the image, and we're going to create a rectangle around that. So as you can see, cv.cv2.rectangle, we're going to take that image and we're going to create a box around the face. What we're also going to do is ROI gray equals gray. So before I get there, let me mention, so this is the image that we're passing to the library, so I create that rectangle around it. As you can see from the comments, the starting point X and Y, the ending point X plus W, Y plus H, and then after that we have the color of the actual square. In this case, we're making it, I believe it's green, with a width of 2 for the width of the line. After that, we're gonna use this line right here, and what this is going to do is going to return the cropped face from the image, and then we're going to get that same image that we got there, and return the details of the image so that we could get the coordinates of that image. So again, these are the coordinates of the face essentially within the image, and this is, like I said, returning that face so that we can place it back onto the image that we're tracking. We're gonna save that data that we get. We're gonna put it inside an array. We're gonna print that array so that you guys will see it once we run the program, but you'll get the coordinates of where the face is inside the image. And then we'll further elaborate with these commands right here and show you a little bit more structured. Oh, sorry about that. And then we're going to do a little bit of some calculations here so that we can scale that data down and make it so that once we pass that data back to the Arduino code, it's a lot more formatted and how do I say this? We basically scale the data of the coordinates that we get from the image so that once we pass it to the Arduino, the values that the Arduino will get and pass it to the servos are within range. So again, so these are the centers. So let me sidetrack on that. So that was not correct. What it actually does, so this is just giving you the values of the X and Y positions of the face, and then the X plus W and Y plus H values. So basically the square around the face. But what this does right here and this is taking those values and doing the calculation where it adds them and then divides them by 2 so that we could get the center of those both X and Y axes of the image, which is then printed out so that we could see them and passed to a format method that makes it so that when we write that data to the Arduino, it's encoded and it's in the format that the Arduino can read. So that was what I was trying to say, but I think I got a little bit mixed up. After that, what we do here is we're actually going to show the image, and again we take that from the img variable, back from when we got this value here. The only difference now is that we have those square boxes and lines on the image so that you can see the face being tracked. Other thing we have here after that is just an escape. So basically cv2.wait key 30. What the 30 means is that it's going to take whatever value that you input, and then we're going to AND that, bitwise AND, with the hexadecimal of FF, which is in binary 8 bits of 1, or 8 bytes of 1. And the reason that we do this is so that we can ensure that the value that's being pressed is the escape button, and that's why we equal it to K. So whenever, I don't know how familiar you guys are with logic operations and bitwise AND, but what it does basically, and what we're doing here, is that we're taking the wait key 30 that we press, which is I believe a byte or a character value, and we AND it with the hexadecimal constant so that we can make that value a number, an integer. I would be able to show you the actual mathematics of this so you could understand it a little bit more, but in terms of time, I think I'll let you guys, if you are interested, look up that line of code and you'll see what I mean. But yeah, after, if k is equal to 27, then we break, and then we basically release that analyzation of the image and then destroy those windows that we created. And that was a little bit lengthy explanation, but it was a lot of stuff to cover. I hope you guys understood what I was saying. But now let's go ahead and write that code. So we're going to create a new file, and then we're going to save that file inside the same folder that we created for the face track Arduino. So we're going to put it in there. You could call this face. Just call it face. That's it. So it's face.py. It should be in the same folder as the Arduino code. We could go ahead and close this now. So the only other thing that would be left for you to have is I'm going to send you guys this actual file because you guys will need this for the demo to work. But it's a hard cascade frontal face default. So I'm gonna copy it. I'm gonna go to my documents. I'm gonna go to face track Arduino, and I'm gonna paste it in there. And now we should be good to go. Only other thing left is to copy this code. And then copy this code. I'll send you the code as well if you didn't already write it yourself. Make sure that it is correctly formatted so that there are no issues. Okay, yeah. Okay, again, let's check to make sure that we have the correct port open. So right now it's not appearing because we don't have it connected, so let's go ahead and connect our Arduino. Let's click on this again. So we're using COM3 as a port, so in the Python script we're going to change this COM4 to COM3. Is there anything else we have to change? I think we are good. Okay, so then what we're going to do is we're going to upload this code to the Arduino. So go to the Arduino IDE, upload the code that we wrote. Looks like we have an error. So it's it's server and let's try that again. previous x, and you put a v there. What else? Previous y. Let's see what we named these initially. Previous v. Okay, I think now it should be good to go. No. Okay, what do we have here? Class hardware serial has no member of a... Oh. Wrote that wrong. Okay, let's really quick go here. Make sure we write that correctly. So AVA. Okay. Let's try this one more time. Perfect. So it's uploading. Done uploading. Cool. So now let's go ahead and get the Python script, and we're gonna save this and run this. Save this and then run this. Well, I think I hit the wrong command or the wrong button. So we're gonna go to run module. You could also press F5, and then it's connecting. Woo! And we got it working. So as you can see my face in the image, and then if you look at the camera, I'll try to do as much as I can. Yeah, so you see, as we go down, up, down, if we go down, then the camera will go down. If we go up, the servo will go up. If we go to the left or the right, it follows. Now, if we were to go a little bit more back and try to do this way, I'll leave this right here so you guys could see it. But it is indeed tracking my face and moving the servos accordingly, which is pretty cool. So now what I'm going to try to do, if I can, I'm going to try to set it up so that you guys could get a little bit of a demo in terms of how this would work if you were to set it up somewhere. And then we would be done with the workshop, and hopefully you guys got this to work as well. If not, make sure to let us know in the comments, and we'll try to help you out with that. But that is basically it for the demo. I hope you enjoyed it. It was quite long, but this is definitely a first for trying to do hardware over the internet and virtually, along with other people. So I hope you enjoyed the workshop. I really enjoyed it. It was a pleasure for me to be able to present this to you guys, especially for ShellHacks. As the director of UP Make, and having hardware be like the main focus of it, bringing you really cool ideas and things like this, it really motivates me because I want to see hardware continuously succeed and grow in the community. So again, hope you liked it. Thank you so much. Make sure to go check out all the other workshops that we're having this weekend. And if you have any questions, we're gonna be all in the Discord. I'm gonna be in the Discord. If you need any help with the workshop itself, or have any questions, let me know and I'll be able to help you. All right. Thank you so much, guys. I really appreciate it. And I will see you guys next time or when I see you. Bye.